Greetings, fellow AGUers, and thank you for watching this presentation on the mass balance of sea ice in Kotzebue Sound, with a focus on addressing research questions designed through a knowledge co-production approach. My name is Andy Mahoney, and I am from the University of Alaska Fairbanks, and I'm presenting this talk on behalf of a team of researchers, all listed below me. The map on the right shows the location of Kotzebue on the northwest coast of Alaska, inside of Kotzebue Sound, which itself lies in the southeastern corner of the Chukchi Sea. And on the left is a brief outline of what we'll cover in this presentation. We'll start with a description of the Iqaluit-Sikukun project and its community-centered approach to research design, including the conception of our research questions. We'll then look at the inaugural data from the first systematic program of sea ice observations in Kotzebue Sound that coincided with the two warmest winters on record and an unprecedented lack of sea ice. Lastly, we'll look at how results from a model-based analysis of these data help address some of the research questions designed in partnership with Indigenous knowledge holders. Iqaluit-Sikukun is Inupiaq for ice bridges, and it is the name identified by Kotzebue residents for a research project that aims to bridge the scientific and indigenous communities to study sea ice change in Arctic Alaska. Despite rapid sea ice loss in the Chukchi Sea in recent decades, the importance of Kotzebue Sound as a habitat for ice-associated marine mammals, and the fact that Kotzebue is the second largest Alaska community north of the Arctic Circle, sea ice in Kotzebue Sound has received little attention from the scientific community to date. The community of Kotzebue is at the center of the Iqaluit-Sikukun project. In our first few months, we established an advisory council of Indigenous elders, John Goodwin, Cyrus Harris, Bobby Schaefer, and Ross Schaefer, who shared their knowledge and took an active role in designing the research that would follow. The rest of the research team included Alex Whiting from the native village of Kotzebue, faculty and staff from Columbia University in New York, the University of Washington, and the University of Alaska Fairbanks, as well as ethnographic filmmaker Sarah Betcher from Farthest North Films. And I'd like to acknowledge the Gordon and Betty Moore Foundation, who took the bold step of funding an extensive multi-year project without predetermined hypotheses or research questions. The distinguishing characteristic of the Iqaluit-Sikukun project that makes it unique among the research projects that I've been involved with is the fact that we began our community engagement before we had designed our research questions. Now, there's a lot going on in the diagram on the right, but as you can see, the box representing community engagement is placed at the top, and the arrows lead from it to the box representing the creation of our research questions and on to the design of our study plan. I should also point out that the arrows keep going around back to community engagement, representing the sharing of data and findings and the circular nature of the co-production process. I'd also like to draw attention to the outer circle, which is labeled video documentary. This recognizes the importance of adopting multiple methods for sharing knowledge created through co-production. And we opted to include filmmaking as a way of sharing the story of Iqaluit-Sikukun in a way that is more compatible with the oral history traditions of the indigenous community. So now I'd like to discuss the research questions that we conceived and refined through a co-production approach during our team's first meeting in Kotzebue. We began with an empty board and asked the initial question, what questions would you ask if you had a fleet of drones and instruments that you could deploy in Kotzebue Sound? And over the course of a few days, we filled this board with sketches, maps, and ultimately 6 research questions related to sea ice in the Chukchi Sea. I won't go over all the questions in detail, but I want to draw attention to the holistic nature of these questions that touch upon sea ice, ecology, and human activities. Each one could be broken into separate questions concerning ice physics, climate, marine mammals, coastal processes, navigation, and hunting practices. But instead, by framing each question from a community perspective, we made connections that would have been unlikely to identify without guidance from our advisory council. It also helped ensure that our findings are relevant to the community of Kotzebue. I should also add that a 7th question, question 6, emerged after our first year of field observations that left the team asking, why was there so little sea ice in Kotzebue Sound in 2018? And this question was amended to include 2019 after our second year of observations. In the rest of this presentation, we will address 3 of these questions related to the length of the bearded seal hunting season, ice and snow conditions affecting ringed seal layers, and what caused the lack of sea ice in 2018 and 2019. For more details on the Ikavik-Sukukun project and our knowledge co-production approach to creating these research questions, I encourage you to see Chris Zappa's presentation in the Science and Society session SY 029. Before I get to the sea ice mass balance observations mentioned in the title, I should provide a quick, simplified explanation of how the spring breakup of sea ice in Kotzebue Sound is related to the bearded seal hunting season. The satellite image on the left is from May 15th, 2016, which was the first day, according to Alex Whiting's journal, that anyone went bearded seal hunting from Kotzebue. This is also the first day, according to satellite imagery, that the channel cut through the landfast ice by the combined outflow from the Noatak, Kobuk, and Selawik rivers was open to the waters of the Sound. Hence, the opening of the channel is one of the conditions that determines the start of the bearded seal hunting season. The image on the right shows ice conditions on June 7th, which Alex's journal notes was the last day that year that boats went out for bearded seals. As you can see, the Sound is largely free of ice, with a long journey across open water to reach any ice where bearded seals might be hunted. For a more detailed discussion of the bearded seal hunting season in Kotzebue Sound, including how it has changed in recent years and the likely impacts for communities like Kotzebue, please see Donna Hauser's presentation in the Science and Society session SY 023, listed at the bottom of the slide. Due in part to the importance of the channel used to reach open water during the bearded seal hunt, we installed several instruments in the ice above the channel during winter, which together comprised our sea ice observing station. In this talk, I will primarily discuss the sea ice mass balance station, which included the snow stakes and hot wire gauges shown in the diagram below me. However, I also encourage you to see Carson Whitty's presentation in the cryosphere session C065, as listed at the bottom of the slide, which discusses the heat budget of Kotzebue Sound and the role of ocean processes in thinning the sea ice. The 2 photos on the left show Kotzebue resident Vince Schaefer measuring ice thickness and snow depth at the mass balance station over the channel. In all, there are 4 gauges where ice thickness is measured and 13 stakes for snow depth. The plot on the right shows how ice thickness and snow depth varied over 2018. The shaded polygons bounded by solid lines show the average measurements, while the dotted lines indicate the range of the measurements. The most striking feature of these data from the 2018 winter is that the ice stopped growing in mid-February and apparently achieved a near equilibrium thickness. This suggests the presence of a heat source below the ice, compensating for the heat lost to the cold atmosphere. In 2019, we were surprised to see the ice stopped growing even earlier in the year, and in fact began melting at the base throughout February and March. We also saw a substantial flooding of the snowpack, which froze to form a layer of snow ice above the original ice surface. To interpret these data, we used a simple one-dimensional ice growth model that simulated growth at the base of the ice, flooding due to the weight of the snowpack, and freezing of the flooded snow to form snow ice. The model is forced by observations of air temperature and snow depth, and derives the vertical heat flux from beneath required to match the observed ice thickness. In 2018, the model indicates that the early end to ice growth was caused by a heat flux from below of around 10 watts per meter squared. The presence of warm water in the channel this late in the year was surprising. The model also accurately captured the small amount of flooding and snow ice formation that was observed in 2018. In 2019, we reran the model to better understand how, despite a colder start to the winter, the ice never even reached the thickness obtained in 2018. In this case, the model shows a heat flux of 10 watts per meter squared was present from early January and increased towards spring, reaching almost 30 watts per meter squared. The deep snow in 2019 was unusual, according to members of our advisory council, and this also reduced ice growth. The combination of the thin ice and deep snow led to a substantial amount of flooding and snow ice formation, which again our model accurately reproduced. 2018 and 2019 were the two warmest winters in the 74-year weather record from Kotzebue Airport. To understand how unusual the ice conditions were in these 2 years, we ran our growth model back in time using these historical air temperatures and the same snow and ocean flux as in 2019. The maximum ice thicknesses reached each year are shown by the blue line below, and as you can see, under these conditions, at no point since 1946 was the ice anywhere near as thin as it was in 2019, which is shown by the dashed red line. In fact, to achieve ice as thin as we saw in 2019 at any other time in the past would have required 50% as much snow and 50% as much heat from the ocean, which is illustrated by the grey line, and it seems unlikely that such extreme conditions would have gone unnoticed. In fact, members of our advisory council report that ice regularly reached 4 to 5 feet thick in the past, that is 1.2 to 1.5 meters. This is illustrated by the purple dashed line at the top of the plot. This is much thicker than anything shown by the blue curve, suggesting that snow depth and ocean heat were likely a lot lower in the past. And finally, let's come back to the 3 research questions I said we were going to address. The first of these questions, question 2, asked, what environmental factors control the length of the bearded seal hunting season in Kotzebue Sound? The results presented here allow us to address the first half of this question, that is, what controls the start of the season. As Donna Hauser shows in her presentation that I referenced on slide 16, boats are typically launched soon after the channel opens up, allowing hunters to reach open water. The photo behind me shows this channel from the air in late April 2019. And prior to this, our sea ice mass balance measurements show that the ice thinned from below by heat from the ocean, which is therefore one control on the start of the hunting season. And please see Carson Whittier's presentation that I referenced on slide 17 for more details of this process and the oceanic source of this heat. The second question addressed by these results, question 4, concerned the snow and ice conditions favourable for allowing ringed seals to make secure dens in which to give birth in spring. Although other Reykjavik-Sukukan activities addressed this question more directly, the measurements made at the mass balance site demonstrated that the combination of deep snow and thin ice can promote surface flooding. Although there seems to be little existing indigenous or scientific knowledge regarding flooded dens, it is unlikely to be beneficial for ringed seals or their pups. Hence, too much snow may be a bad thing for ringed seals if the ice is too thin. The photo behind me shows a flooded lair found by our team in 2018, and current climate projections suggest that the combination of thin ice and deep snow may become more common in the future. And lastly, our measurements also help address question 6, which arose during the course of the project and simply asked, why was there so little sea ice in Kotzebue Sound in 2018 and 2019? Our measurements and model results suggest that the ice in these 2 years was unusually thin due to heat from warm water below. And oceanographic data from our sea ice observing station suggests that this heat came from outside Kotzebue Sound and therefore likely contributed to the absence of sea ice within the sound, which was in turn related to a more widespread lack of ice in the Bering and southern Chukchi Seas. It's likely that this was residual heat left over from summer warming of the ocean, which was not lost to the atmosphere over the course of freeze-up. Our growth model suggests that the little ice that did form in 2019 was probably the thinnest in over 70 years. And with that, I'd like to thank you again for watching this presentation, in which I hope you've seen how knowledge co-production and community-created research questions can lead to a more holistic understanding of the changes taking place in the Arctic. I'll leave you with this satellite image of Kotzebue Sound in April 2018, which at the time marked an unprecedented event of a kind that requires the partnership between scientific and indigenous communities to fully understand the significance and implications.